All right, hi everyone. Welcome to the second day of the Public Sector Summit. I'm Leo Jadnowski. I'm a Principal Solutions Architect here at AWS. And this morning we're going to be talking about continuous integration and continuous delivery on AWS. So I'm going to be talking to you about just DevOps in general and the services that you could use to do continuous integration and continuous delivery on AWS. And then Sheng is going to be talking to you, or he's going to be doing a demo of our services for you. So let's get started. So why does DevOps matter? So DevOps matters because according to the State of the DevOps report from 2015, high-performing IT organizations deploy 30 times more frequently with 200 times shorter lead times, and they have 60 times fewer failures and recover 168 times faster. So those are some serious metrics right there, right? That makes a big difference if you can do that for your organization. Also, lean management and continuous delivery practices create the conditions for delivering value to your customers faster and more sustainably. And high performance is achievable whether your apps are greenfield, whether they're brownfield, or whether they're legacy. So let's just define terms before we really get started here. So what's continuous integration? What's continuous delivery? So continuous delivery is a software engineering approach in which you keep your producing software in very short cycles, so you deploy quickly, and that you ensure that your software can basically be released at any time. So at any given time, I should be able to essentially hit a deploy button, and my code in its current state, assuming it passes tests and all that, should be able to get deployed to staging or to production, depending on how you have it set up. And then continuous integration is the practice in software engineering of merging all your working copies of developer code into a shared mainline branch several times a day. So some advantages of continuous integration is that changes to your code are automatically deployed to your mainline branch, and this should depend, though, on passing tests. So you have unit tests, you have mock tests. You can also do security testing as part of this, UI testing as well. So assuming your code passes testing, it's going to get deployed all the time. It makes changes to your code iterative and not monolithic. So I've seen some organizations I work with go from deploying code for a given app 4 times a year to 10 times a day. And so what that means is if you're deploying something 4 times a year, you can afford to probably manually deploy it. And if you're manually deploying it, there's a lot of room for error, right? Every time you're doing something with your hands. So there's a lot of things that can go wrong there. And if things do go wrong, there's a lot of code that's changed, if you're deploying 4 times a year. So if you're deploying 10 times a day, your code changes are very small. They're iterative. You can pick up if something goes wrong immediately, and if something does go wrong, you can fix it really quickly. And so failure takes on a different meaning, and it means that you can move a lot faster. You can actually, it's okay to fail. You can fail fast. You can recover from failure fast, and you can deliver software much faster to your customers. So bugs are detected quickly. This also kind of acts as a forcing function toward automation. So again, if you're deploying 4 times a year, it's probably feasible to do it manually. If you're deploying 10 times a day, it's not feasible to do it manually. So that means you have to automate your deployments, which also has a lot of benefits and helps you out. And so ultimately, this leads to rapid deployment and rapid development. So what does this actually look like for a developer? So you're a developer, you've got your source code repository, so that could be Git, it could be Subversion, whatever you're using, Team Foundation server. You've got your continuous integration server, so that's something like Jenkins or CloudBees or some other continuous integration software. You've got your project management server, so that's something like Jira, where you're just keeping track of what you're actually working on and who needs to work on what. And so as a developer, you pick your tasks from, let's say, your Jira. You write the code for the task at hand. You commit the code to your source code repository, so something like Git. That triggers a build. So the build will happen typically in your continuous integration server, You can also have recurrent builds, so builds that happen, say, every midnight, and then you do extra load testing on them. And so what happens when the actual build happens is your continuous integration server will pull the code. You're working with Git, for example, it'll pull that specific commit that you just committed. It builds the code, it runs tests on the code, and it shows you the results of those tests. So if the tests pass, you can then go on to the deployment stage. So you have build output, right? So the build output's either going to be in the form of packages, it could be in the form of binaries, it could be in the form of documentation that's automatically generated, it could be in the form of dev-facing notifications. So you're going to get an email, or you're going to get a notification in your Slack or HipChat, whether your deployment actually passed or not. So another thing that we see customers doing is called immutable infrastructure. So in this method, what you do is, instead of deploying to the same set of instances and you're recycling them all the time, you actually build new instances, or if you're using Docker, you deploy new containers. So that has several advantages. If you're deploying new AMIs or new Docker containers, every time you deploy, you're essentially building up a whole new architecture. And so your old stuff's still there, right? So if you have to fail back to the old code, you don't have to redeploy. You just repoint DNS to your old code. So failback's a lot quicker. The other big advantage of it is that it's a lot more secure. So if you're automatically building your images or containers all the time, that means that the average lifetime of any instance or any container is pretty short. And so if something gets compromised, the attacker won't be on there for long because anything in your architecture doesn't actually exist for that long. And so the other thing it allows you to do is you can eventually disable login. So you can disable SSH in some cases. And if you can disable SSH, that makes it a lot harder to break into something because everything's being built with automation, so there shouldn't really be any reason to log in. So let's review the traditional components of how you do continuous integration, continuous delivery on AWS. So you've got your deployment software, typically on your laptop. So this is something like Capistrano or Fabric, or there's a bunch of tools to do that. Then you've got your Git repository. So the Git repository is on GitHub, or it's on an EC2 instance running in your account. You've got your continuous integration software. So that is something like Jenkins. That's also running on an EC2 instance. You've got your project management software. Again, that's Jira or something like that, also running on an EC2 instance. And you put your build artifacts if you're building packages. You put them in S3. If you're building Docker containers, you're probably going to use our container registry service. And so as a result, if you notice, a lot of this stuff is things that you have to manage. So EC2 instances that you have to administer, you have to make sure they stay up and running. You've got your laptop as an integral part of the deployment process because you're kicking off the deploys from there. So this works, this is good, but there's a lot of things that can break. So as a result, we've, in the last few years, come out with some new services that take some of the undifferentiated heavy lifting away from you to do this. So we're going to talk about AWS CodeCommit, AWS CodePipeline, and AWS CodeDeploy. So let's look at the typical cloud software development lifecycle. So we've had services that covered deploying your code, provisioning your code, and monitoring your infrastructure for a while. So we've got Elastic Beanstalk, right? So Elastic Beanstalk allows you to take code, it allows you to deploy it onto EC2 instances, it sets up your auto-scaling groups, it sets up your ELBs, it sets up your RDS instances if you needed to. It works with a bunch of different containers, so it'll work with PHP and Ruby and .NET and Python and Java and Docker containers, and I'm pretty sure I'm missing some. So it supports a lot of different containers. Then we've got OpsWorks. So OpsWorks is essentially managed Chef. So OpsWorks runs an agent on your instances, and you can drop Chef recipes in. And the Chef recipes, so Chef is a configuration management system. It's basically based on Ruby. So it allows you to do things like update packages, add users with automation. Then we've got CloudFormation. So CloudFormation is a service that allows you to treat your actual infrastructure as code. So you can write a JSON file. That file essentially controls everything above the instance, including the instance too. So you can have your VPCs, your ELBs, all your actual services, not just your instance, described in your CloudFormation template, and you can deploy off that template. And then we've got CloudWatch and CloudWatch logs, and that gets you metrics on your instances. It gets you logs, right? But what about storing, keeping track of your code, building that code, and testing the code? Well, that's where our new services come in. Let's talk about CodeCommit. So CodeCommit is a managed Git service. It is based on Amazon S3. The nice thing about it is it's fully Git compatible. So if you're already using Git, it is the Git experience. You're using the same Git client tools that you would use anywhere else. So it's really easy to get started. It's got all the benefits of a cloud service. So it's built to be scalable. It's built to be inexpensive. It's built to be reliable. It's built to be durable. And it's also got no size limits on your repositories, so you can put as many objects as you want in your repository. You can store really big files in there if you want to. And it's got an online web console. The web console shows you your code. It shows you, what the current state of your code is. And so the experience is exactly the same, again, as using Git. So in this example here, I'm committing, or I'm cloning a repository. Once that repository is cloned, I'm changing the README file. I'm committing my changes to the README file. And I'm pushing the code back up. And as you can see, this is the same exact thing as if I was using Git with any other service. Then we got CodePipeline. So CodePipeline is our continuous delivery service. CodePipeline allows you to model and visualize your release workflow, so you can visualize how your code goes from source to testing to building to deploying. It's pretty flexible. It works with a lot of third-party tools. So as we'll show you in our demo later, you can do integration with load tests in it. You can do integration with CodeDeploy, with OpsWorks, with Elastic Beanstalk, with a bunch of AWS services. And it helps you automate your builds, your tests, your deployments, and it handles it in a scalable, reliable manner. So lastly, we have CodeDeploy. So CodeDeploy is a service that allows you to deploy your code on a set of EC2 instances. It is integrated into auto-scaling. So if you're deploying your software into an auto-scaling group, you could have 2 instances. You could have 100 instances. You could potentially have 1,000 instances. And so in that scenario, it's typically hard to deploy because you don't know what you're deploying to. You could have a lot of resources that you're deploying to, and you don't necessarily know their names. They're ephemeral. The instance names change because they cycle in and out. Well, CodeDeploy takes care of that for you. You just say, I want to deploy to this auto-scaling group, whatever is in it. You could also deploy to instances based on tags with it. You could deploy to on-premise servers with it as well. It has got auto-scaling integration. It's got ELB integration. So if you have a bunch of instances behind ELB, it'll know that. And it allows you to reuse existing tools. So in CodeDeploy, you can either have it control your deployment from start to finish. So you can have it install package updates, install your actual code, run any arbitrary scripts. Or you can say, OK, run the CodeDeploy agent on boot, connect to my Puppet Master, connect to my Chef server, connect to Ansible, and let your existing tool that you're using to configure your instances take care of the rest. So it's very flexible, and it really works back with any, it works with essentially any application. And it also provides for easy rollback and easy, safe deployment controls. So you control the schedule in CodeDeploy. So if you're deploying to testing or staging, you can just say deploy to everything at once. If you're deploying to production, you want to be really safe, you can say deploy to 1 instance at a time, and if that fails, stop. So now we have AWS managed services for the whole cloud software development lifecycle. So with those services, the components of doing continuous integration, continuous delivery on AWS become a little bit more simple. So now you can use CodePipeline for your work, for your actual pipelines, and to manage your code from source to build, to test, to deploy. You can use AWS CodeCommit for your software repositories. You can use CodeDeploy to do the deployment. You still probably need something like Jenkins to do your continuous integration, but traditionally, people use Jenkins for what CodePipeline does as well. And there's some issues there. There's some risks, right? So when your Jenkins instance is deploying everything, that means it's got a lot of permissions on it. That means it potentially has a lot of AWS permissions to the various APIs. And so if someone were to get into your Jenkins instance, they could potentially do a lot of damage. With this, you're using Jenkins just to run tests here and there, just to run builds perhaps, and that's a lot less risky. That requires a lot less permissions. So that's a big advantage there. And the reason I have the star there is you can also, we have a service called AWS Lambda. So Lambda is a serverless service. So basically you send it your Python or Node.js or Java code, and it executes that code without even having to spin up any instances. And you pay per millisecond of execution time. So you could potentially port some of your tests and some of your builds over to Lambda. It depends on how long those take and what they do, but you could potentially do that and have Jenkins do even less. You still need your project management software, right? And you still put your build artifacts in S3, or you can use the container registry if you're using Docker. Another thing that we have that's a good resource is our DevOps Partner competency program. So basically, it's broken up into two different verticals here. So continuous integration and delivery and configuration management. So these are just partners that we work with where we ensure that their solutions work well with AWS and use all of our best practices. So you can find more about this on our website. So we're going to be doing a demo today. So let me just talk you through kind of what we're going to do in the demo. So actually, we're going to be using CodeCommit to store our code. And the code is going to be a WordPress site just for the demo. So we've got our code in CodeCommit. We're going to use CodePipeline to build that code and test it. We're going to use CodeDeploy to deploy that code. We're going to be using CloudWatch to get some metrics on it, and New Relic to get some more detailed monitoring on it. We'll show you how all that works. So the architecture of what we're going to be doing in the demo is going to look like this. So we've got WordPress. So WordPress is a PHP content management system. We have our WordPress broken up into 2 availability zones. So that way, if we lose an instance, or even if something happened in the availability zone, we'd still stay up. There's an ELB in front of it. It's also in an auto-scaling group. So if we get a sudden spike in capacity, we're going to add more WordPress instances if we need to. We have Jenkins on an EC2 instance. Jenkins is going to be managing testing the WordPress code whenever we deploy it. And then the database is going to be on Amazon RDS. We're using RDS multi-AZ. So again, our relational database is going to be highly available. If we needed to, we could also spin up read replicas for it, but we don't need to for this case. And something I don't have on this architecture diagram is we're also using Elasticache from Memcached. So that helps our WordPress instances actually be sessionless, right? So because the web servers are in an auto-scaling group, they can go away. We can add new ones. We don't want to be storing session state on them. We want to be storing it somewhere else. So we're storing it in Memcached. Memcached is also storing its caching database queries. So it reduces the amount of times that RDS even gets accessed. So if there's and you can see this in the New Relic monitoring, if there's a load test, a lot of the most common database queries just come straight out of Memcached, which is stored in memory, so it's really fast. So it increases the availability of or increases how much your website can take, how much traffic. Also, we have S3. So we're putting all of our static assets in S3. So that also takes a lot of load off the web server. And because we want our static assets to be displayed really fast, no matter where someone is accessing our website from the world, we have a CloudFront distribution in front of the S3 bucket. So that's basically our architecture that we're working with. And this is how deployment's going to work. And again, actually, we're using CodeCommit instead of GitHub for today's demo. So if you're a developer working on our website, you put any code changes into CodeCommit. CodeCommit then kicks off CodePipeline, or CodePipeline does a build or a test on Jenkins. Assuming that test passes, it triggers triggers CodeDeploy to a staging auto-scaling group. Then that staging auto-scaling group, assuming that deploy is successful, triggers a managed load test through BlazeMeter, which is one of our partners. Assuming that load test passes, we do another deploy into production. And then after production, we can take a look in New Relic, and we can see if this deployment has increased speed, what the metrics are around how well our website's doing, and it gives us a lot of information. So I just described everything that happens here, so I'm gonna skip this. And let's also talk about how CodeDeploy works a little bit. So in CodeDeploy, there's lifecycle events. So what that means is when a new CodeDeploy starts, you've got your instance. Your instance is running the CodeDeploy agent, which is talking to the CodeDeploy service. So when there's a new deploy, the instance is notified, hey, there's a new deployment. This triggers the application stop stage. So in the application stop stage, I'm deregistering my instance from the load balancer, from the ELB. And the reason I'm doing that before stopping my web server is that if I just stop the web server, I'm relying on the ELB's health check to see that the instance is not healthy anymore. And so I don't want to be, and there's a threshold on that, so I don't want to be returning a few errors to my users when I can just deregister from the load balancer and then not have that happen, right? So the next stage is download bundle, so it's going to download my code from S3 that I'm deploying. The next stage is before install. So in this stage, I'm deleting the old version of my code. I'm installing any dependencies I need. I'm installing the New Relic agent or any other agents I need on my instances. Then I'm actually installing the code, the WordPress code itself. So it's going to take that zip file from S3 with my source code. It's going to unzip it in the proper location. Then we have the after install stage. So in the after install stage, I'm updating permissions. I'm just doing some chmods. I'm downloading my config, my WordPress config, which has my SQL credentials in it, and any other creds that I need. And I'm marking the deployment in New Relic. A really important thing is, why am I downloading my creds during this? Well, I don't want to have my MySQL credentials, or if I have any AWS API keys, I don't want to have those stored in Git. Because what can happen is, traditionally, we've seen customers, they'll host their code in Git, right? They put their credentials in there. It accidentally goes into a public repo. Then your keys are public, and then you get compromised. So you don't want that. So instead, what I'm doing is I'm using an IAM role on my web servers. That IAM role gives my web server access to an S3 bucket that's private, and my instance can download the WordPress config file, which has the creds that I need. I can also use encryption on that file if I want, and it downloads it. And so that way, if my code leaks, I've got no credentials in there. So it's way more secure. Then we go to the application start stage. So I'm going to restart my web server. I'm going to re-register this instance with a load balancer. So it's going to start serving traffic again. And lastly, there's a validate service stage. So basically, I'm verifying that my actual application returns a 200, and it's healthy. And CodeDeploy is then notified whether this deployment's been successful or not. So let's talk a little bit about code deployment, default deployment configs. So if I'm doing something and I don't care about risk, I just want to deploy really quick, I can do it all at once. So it's going to deploy to all of my instances at once. If I'm a little bit more risk conscious, I can do half at a time, right? So it'll deploy to 3 of them if I have 6. If that succeeds, it'll deploy to the other 3. If it doesn't, then it stops and I still have 3 healthy instances. And then if I want to be super, super cautious, I can do one at a time. So it's just going to deploy to 1 instance at a time and stop if there's a failure. I can also do custom deployment configs. So I can say, let's say I have 100 instances. I can say I want no less than X amount of hosts, so let's say 10 hosts, to be healthy at all times, regardless of the number of instances. I can also do fleet percentage. So I can say I want no less than 80% of my hosts to be healthy during the deployment. So it's pretty flexible how you do your deploys. Let's take a look at how failed deployments work in CodeDeploy. So let's say I'm deploying a new version. I'm going to deploy to 1 instance. If it worked, I'm going to deploy to the second one. If it worked, I'm going to deploy to the third one. If it didn't work, that makes the deployment a failure. And so if the deployment has failed, or if I cancel the deployment, we just stop. We don't automatically roll back for you because we don't want to assume that's what you want. So what happens is you would do another deployment with the previous version of your code and redeploy it again. And in the meantime, the state of your instances will be whatever they were when the deployment stopped. So now we're going to have Shang come up and do a live demo.
All right, my name is Shang Xie, and I'm also a solutions architect in AWS. Today, I'm going to do a live demo for you about the service Leo just described and about the CI and CD process. So the first thing I did is I create a bunch of instances for my environments. As you can see from EC2 dashboard, I have 2 staging servers for my staging environment. They're behind a load balancer in an auto-scaling group. I also have like 4 production servers. They're in different availability zones, also behind a load balancer in its own auto-scaling group. I also have a build server, which has Jenkins installed to do some testing for me. So that's basically my environments. So the next thing I want to show you is the code pipeline. The reason being is I'm using code pipeline to manage my continuous delivery process. So I have a bunch of code pipelines already configured and installed. So what I'm using today is the first one, demo pipeline. So before I do this, I do have already made some changes, and I'm going to commit my change and just do a push. All right, so I'm using CodeCommit to host my Git repository, so that's the change I pushed to. So I'm going to walk through a little bit later for the CodeCommit repository. So let's go back to the pipeline. So in my pipeline, you can see it's 5-stage pipelines, starting from source. Okay, just to refresh. Yeah, you can see the first stage is source. It pulls the changes from my Git repository, which I just committed. So it's already started in progress. Hopefully, when I finish talk, my change will be deployed to my production environment. So in the code pipeline, the second stage, when it pulls code from the repository, it will just using the Jenkins server to do some testing. After my code passes the testing, then I'm going to use CodeDeploy to deploy my change to my staging environment. After my staging environment deployment, I'm going to use a tool called BrazeMeter to do some load testing. BrazeMeter is from our partner. They provide some, they call test as service. So once my load testing is passed, my final stage will be production deployment. Again, I'm going to use CodeDeploy to do this deployment. So the next thing I want to show you is how the code pipeline is configured. Let me click the edit button. Then you can see code pipeline has different stages. In each stage, we can define multiple actions. So if I click this, you can see we can define actions sequentially. So I can have action 1, 2, 3, they run just in sequentially. And I can also define actions run in parallel. So in each stage, it's pretty flexible. You can do lots of different things. Then between 2 stages, you can also insert a different stage. For example, if you want to do some compilation because you're using Java or C++, you can insert a build stage, just do the compilation for you. So I'm going to, for each action, you can choose from different categories. So we already have something predefined for you. The first one would be source. Basically, it pulls the source code from your source repository. Right now we support 3. The first one is CodeCommit. Then we also can pull source code from S3 bucket and also have a GitHub repository. The next one would be build. For build, you can use Jenkins, or you can use some other tools called Solana CI. It's also our partner. They provide some continuous integration build tools. The third one would be test. For test, we actually have a little bit more third-party tools you can choose. We can use Braze.me to do load testing. We can use Longscape, Jenkins again, and some other vendors if you choose. Oh, all right. I actually want to show you the deploy. In the deploy action, if you already use like OpsWorks or Elastic Beanstalk, you can continue to use this. You can also use CodeDeploy to do your deployment. And the last one is Invoke. Invoke is a very nice feature, new feature. You can use our Lambda function to do your customized actions if you want to. It's very flexible, so basically you can upload some code to a Lambda container and it just runs for you. So that's my code pipeline. So I'm not going to make my change. So you can see my change already passed the testing stage. So it's running deployment in my staging environment right now. But before I show you that, I'm going to my code repository. So as Leo mentioned, it's our fully managed Git service. So you can host your private Git repository. So it has a very nice, simple interface. You can have a code browser here, so you can look at the code. Then you can define some triggers here. The trigger have two options. You can use our simple notification service to send out a notification. You can also run a Lambda function to do something you want to do. So right now I have my notification defined. Basically means if anybody push a change to my master branch, I will receive an email via our SNS service. So let me just quickly go to my Outlook. So you can see from here, I already received an email from my code repository saying, okay, I already commit a change. You probably cannot see the email very well. Basically it says like, yeah, this is my username, and I pushed a change to my master branch. So that's very nice, because if you're working with a distributed team, all over the world, then you want to collaborate with each other, it's nice to receive some notifications if somebody push a code to your integration branch or master branch or whatever, so you can do something. Okay. So that's my repository. Next thing would be my Jenkins server. So as Leo mentioned, in Jenkins here, we just use it to run some tests. We're not going to use Jenkins to do any deployment. So we have a CodePipeline plugin for Jenkins you can use. So you can pull source code from CodePipeline. That's a plugin configurations. So it's in US East. So the category would be test here. Then I have a schedule runs for every minute, which means it will pull my code repository every minute to see if there's any change. If there's any change, it will try to run the test for me. Since I'm using EC2 IAM role, so I don't need to put my access key over there. So if you run it from a different account, then you probably have to put your access key and the secret key over there. And there's also some code pipeline polling log. So it gives you some logs, say, okay, I pulled the code from my code pipeline and just run the test for me. Again, I want to show you, I forgot to show you the test. So my test is really simple. It's not really good one. It's basically echo, everything looks good. So you probably can do a bad job over there. You can, you can run any scripts, and for example, it's a PHP, so you can use PHP unit testing over there, and also some other JUnit, whatever you want there, and make sure it works fine for you. If it fails, then it can send out a notification or stop over there. So it's running good. So I already finished my deployment to my staging environment. So the next thing I'm going to show you is CodeDeploy. So in CodeDeploy, the first thing you have to do is to install the agent. So you can have a couple of choices over there. You can use whatever CM tool you like to, like Chef, Puppet, to install it, or you can also use EC2 user data if you're familiar with that, to install the agent for you, or you can just pre-install and do a customized AMI and just use this AMI to install your application. So the agent will be there. The next thing you need to do is you have to create some file called app spec. It's a YAML file in your repository. That's the only thing you need to do in your repository. I'm going to show you this later, but right now I'm going to show you that CodeDeploy has a concept called deployment group. So you have to define some deployment group for your environments. So if you can see from here, I have 3 already defined. That's my production, that's my staging. So for the staging environment, you can see I have my configuration doing like 1 at a time, so which means I will deploy to 1 server at a time. And for production, because I already passed my test, I have more confidence, so I'm just going to do half at a time. So from here, you can also see they have triggers. So you can create some triggers to send out notification for you if you choose to. So from my compiler, I can go to details. So that lists the deployment which just happened in my staging environment. So you can see I have 2 staging servers. They're both successful, and my screen is too small. Then you see at the bottom we have events. So if you look at those events, they're really familiar, just like as Leo described. Those are lifecycle events happen in CodeDeploy. So for each lifecycle event, you can define some actions to do. In order to do this, let me go back to my sorry. Oh, just lost it. Oh, okay. Oof. Live demo is always dangerous. Like, I don't want to. So. First thing I want to show you is, hopefully you can still see, that's the app spec YAML file I just described to you. That's the only thing you have to do in your code repository. Basically, this config file defines a few sections. The first section will be about files, so which it means like if you want to copy some files from source to some destinations, you can do it from here. Then you can see we copy a bunch of configuration files from our source location to the destination. Then we have some permission sections, basically just to change a mod, change ownership, change group, so you can have prop permissions for your configuration files. Then the import section would be the hook section. That section actually maps to your lifecycle events. Then you can see before install, we want to run some scripts. Then after install, we run some additional scripts. Then we have application start, application stop, these kind of things. Back to show you the script we're really running. So for example, this script we're doing after installation. So basically it installs a new Redux agent. So after our application up and running, we can do some monitoring over there. One thing I want to show you is there's an environment variable called deployment group name. This environment variable is passed by CodeDeploy. The important thing here is when you do deployments, a lot of times you know which environment you're in, right? Because in a production environment, you probably want to connect to your production database instance. In a staging environment, you want to connect to a different database instance. The way you can know is based upon these environment variables, it passed to you. Then if it's staging, it will be just staging, and in production, it will be production. So no, you know different environment you're in. The other script I want to show you is the install crafts. This script is pulling some configuration files from the S3 bucket. As Leo just described, like I mentioned, you don't want to save your credentials, like user ID, password for your database into a property file and just leave it on a server or leave in your code repository. So the way we did it is we put into a S3 bucket, have very restricted permission, and we also encrypt. During the deployment, we pull this file from our S3 bucket, so it will have all the information it needs. Also, you can do it based upon environment. If it's production, you pull a production config file. If it's staging, you pull a different configuration file. So I'm not going to show you all my scripts. A lot of scripts just very simple, like 1 line, 2 lines. Like for example, before installation, we do a like YAML update, just basically update to apply all the patches. So just like 2 lines. So the next thing I'm going to show you is my load testing. I think I have it already in. So that's my load testing result page. So you can see every time we deploy to a staging environment, we would like to do a load testing. So we have some confidence about our applications. So from Blaze Meter, you can see we have right now like 49 users do some HTTP hit requests. Then we have some error rates, then the average response time, load time, these kind of things. The nice thing about the Blaze Meter is when you do load testing, typically you don't want to do it from one server. You want to do it like from some distributed areas, distributed servers. Blaze Meter can do this for you. So you can choose actually, they said like 10,000s of users to do the same load test for you. So it will be really useful for you. For my demo, I'm just using like 49 users. You can do a lot more from here. And you can see we have the load time, response time. If I show you the threshold, I define my threshold as like if my HTTP request exceeds 2 seconds in average, then my test will fail. Then if my error rate is more than like 5%, like here, it will also fail. So after my load testing, I have some confidence that my application will be launched just fine, even I have some load. Okay. So right now, I passed all my tests. My deployment is happening in my production environment. Let me show you real quick. So in my production environment, as I mentioned before, I have like half at a time. So you can see. Oh, that's not good. Oh yeah. 2 already like succeed, and 2 are in progress. So because they're in behind like a load balancer, so it's like when they deploy, we will suspend them in the load balancer, so they will not receive any traffic. Basically, they're in a standby state. So when we finish the deployment, they're up running, we're happy with the service, we put them back to the load balancer. So you will not have any outage in your service. So let me, again, view the events real quick. So basically, that's the same thing I showed to you. So it takes some time to go through all the actions to pull the changes. Okay, I'm still waiting for my last server. Sorry, it takes a little bit of time. In my practice, it should already finish. But in the real but anyways, even I only have 3 servers running, then Leo's blog should be up running already. That's his blog. So, okay, that's his awesome blog. To summarize, so I demoed like we're using all our like code service to manage the continuous delivery and have a very nice process. So the only thing I did here, you can see, is I just commit my change, push it to the code repository, then it kicked off the whole process. So as a developer, I can move on to my next assignment, or I can just go grab a coffee. When I come back, then it should be already in the production, right? So I will be very happy, then the manager will be very happy. It will really improve your productivity So that's my demo. Thanks.